Hello everyone, welcome back to uLearn Education Online channel. Now in today's video, we are going to see the concept of modulation index in amplitude modulation. So in today we are going to cover the concepts, that is what is modulation index and why it is important in the communication system, and what is the time domain expression of amplitude modulation in terms of modulation index. Since in the previous video we have seen how to derive the time domain expression of amplitude modulation, and also for an waveform how we are calculating the modulation index, and how the amplitude modulated wave will depends on the modulation index value. Now let us start with what is a modulation index. So practically or mathematically, the modulation index is defined as the ratio of the maximum amplitude of a message signal, that is AM, to the maximum amplitude of a carrier signal, that is AC. So mathematically I can write the modulation index value as M is equal to AM by AC. So it is indicated with either the notation M or mu. Sometimes this modulation index is also called as a depth of modulation or degree of modulation. Now why we have to study the modulation index? What is the significance of modulation index? So this modulation index is the only parameter which defines how much percentage of baseband signal or a message signal that can be recovered at the receiver end. So what is the communication system will do? Simply whatever the baseband signal is generated from the information source, that baseband signal is transmitted through the channel. So while transmitting through the wireless channel, we are using a modulation technique. So we are converting the low frequency signal to the high frequency signal with no information change, and thereafter we are transmitting through the channel. So at the receiver end we have to use a demodulation circuit in order to recover our original baseband signal that is transmitted at the transmitter end. So how much percentage of recovery rate will be, that is indicated with the parameter modulation index. So for the lower values of modulation index, we can definitely say that the original signal can be retrieved perfectly. For example, if M is 5 or 6, means if the modulation index values are greater than unity, then we can say that the recover signal at the receiver end, means the recovered message signal will be gets distorted or some information loss will be present while retrieving our transmitted message signal at the receiver end. So this parameter is very important in the communication system. So depending on the modulation techniques, this modulation index value will be defined. Okay, so for AM modulation we can define as the modulation index as the maximum amplitude of a message signal ratio to the maximum amplitude of a carrier signal, that is M is equal to AM by AC. Now we are going to see how to derive or how to express the time domain expression of AM wave in terms of modulation index. So as we know that the amplitude modulating wave equation in terms of time domain is, that is S of t, we can write as C of t, that is carrier signal, into 1 plus Ka M of t. Okay, so in the previous video we have defined that C of t and M of t is nothing but a cosinusoidal signals. So I can write the C of t expression as AC cos 2 pi fct and M of t expression as AM cos 2 pi fmt. Okay, and we know the Ka is nothing but an amplitude sensitivity and its value is 1 by AC. Now simply substitute these three expressions in S of t equation, then we will get the expression S of t as AC cos 2 pi fct into 1 plus Ka is 1 by AC, AC into M of t is AM cos 2 pi fmt. Okay, so we can write AM by AC as the modulation index value, since the modulation index of AM is defined as a ratio of amplitude value of message signal to the amplitude value of carrier signal. So finally the S of t expression in terms of modulation index as AC into 1 plus, I can write AM by AC as modulation index M. So it is 1 plus M into cos 2 pi fmt into cos 2 pi fct. So this is the final expression of time domain AM signal in terms of modulation index. So this is the final expression. Now we are going to see how the AM waveforms will looks like for different values of modulation index. Okay, so let us see, this is the waveform. So this waveform will appear when the modulation index value will be less than unity. Okay, this waveform we are calling it as an under modulation AM wave. Okay, so this is the modulation when m is less than 1, then this under modulation AM wave will be transmitted through the wireless channel. So in this under modulation AM wave, we can definitely say that at the receiver end our message signal will be 100% recover. Okay, so there is no loss of information when we transmit the baseband signal with the modulation index less than 1, that is we are calling it as an under modulation AM wave. Now let us see when the modulation index is equal to unity. So when the modulation index is equal to unity, so from the definition, that is AM by AC is equal to 1 implies the amplitudes of message signal and carrier signal are equal. So here we are calling this modulation as a critical modulated AM wave. Okay, so what happens when the baseband signal is transmitted through with the critical modulated AM wave? So in this critical modulated AM wave, some information will be lost while transmission, or in other words we can say that there is a loss of information in the recovering of original signal at the receiver. That loss of information may occur because of the modulation index value or the high strength of noise that is present in the medium. Okay, so practically the under modulated AM wave is used. Theoretically we can consider the critical modulated wave in some cases. Now let us see what happens when the modulation index is greater than 1. So when the modulation index is greater than 1 implies the AM by AC value is greater than 1 implies the amplitude of message signal is greater than the amplitude of a carrier signal. So this case we are calling it as an over modulation AM wave. Okay, so what happens when the modulation index is greater than 1? So if we observe this waveform, so whenever the modulation index is greater than 1, it leads to the phase reversal. Means here if you observe, the signal is ended with the negative cycle, whereas at this point again the signal is started with the negative cycle. Means there exists a phase shift of 180 degrees. Okay, because of this phase reversal we can say that these phase reversal points indicates that at that point the information will be lost. So in the over modulation AM wave, at the receiver end 100% of information will not recover. So this over modulation AM wave is not practically used. Why? Because it leads to the high strength of noise, and also 100% the original signal will not be recovered at the receiver end. So these are the waveforms of modulation index for different values. Let us consider m is less than 1, m is equal to 1, m is greater than 1, how the waveforms of AM wave looks like. Now let us see for this any one type of waveform how we are going to calculate the modulation index practically. So here I am considering the AM waveform with the modulation index m is less than 1. Okay, so we are calling this waveform as under modulated AM wave. So here if you observe, this is the envelope of a message signal. So this envelope of a message signal is having a maximum amplitude. Let us assume that it has A max, and this envelope is having a minimum amplitude, that is A min. Now next question is, what are the values of A max and A min? So if you clearly observe, this A maximum is nothing but both the amplitudes are added up. So here the carrier signal amplitude is varying according to the amplitude of a message signal. So we can write that the A maximum or the maximum amplitude of under modulated AM wave as AM plus AC. Okay, so this is equation 1. Let us consider. Now what is the value of A min? So here we have to maintain a point, that is we are considering that is m is less than 1 implies AM by AC is less than 1. So that is the amplitude of message signal is less than the amplitude of a carrier signal. So while finding out the minimum value of the under modulated waveform, we have to maintain this condition, that is AM is less than AC. So by assuming that, I can write the minimum value as AC minus AM. Let us consider this as a second equation. So we know that from the definition of modulation index, m is equal to ratio of amplitude modulated wave, that is AM by AC. Okay, now we have to find out the values of AM and AC. Thereafter we will substitute in this modulation equation. Let us consider it as an equation 3. Now in order to get the AM value, simply subtract equation 1 and 2. So I can write equation difference equation 1 minus 2, then I can find out the AM value, that is A maximum is AM plus AC and A minimum is AC. So I can write this is AC minus AM. Okay, so if I find out the negative, that is minus, then it is, I can write A max minus A min is equal to AM plus AC minus of AC minus AM. So AC gets cancelled. So finally you will get the AM value as 2 AM is equal to A max minus A minimum. So finally the AM value is AM is equal to A maximum minus A minimum by 2. Okay, so A max minus A min by 2. So this is the value of AM. So in order to find out the value of AC, simply add the equations of 1 and 2. So if you add the equation of 1 and 2, so what is the first equation? That is A maximum is equal to AC plus AM and the A minimum is equal to AC minus AM. Now we have to add these two equations in order to get the value of AC. Then I can write A maximum plus A minimum is equal to AC plus AM plus AC minus AM. So AM gets cancelled. So finally I can get the value of 2AC is equal to A maximum plus A minimum. So finally the AC value is A max plus A min by 2. Now we have find out the value of AM and AC. Now simply substitute the values of AM and AC in the definition of modulation index. That is M is equal to AM by AC. Now what is the value of AM? So AM is A maximum minus A minimum by 2 divided by AC maximum is A maximum plus A minimum by 2. So these two will get cancelled. So finally the value of modulation index is A maximum minus A minimum by A maximum plus A minimum. So this is the procedure how to calculate the modulation index value for the given waveform of amplitude modulated wave. Thank you so much for watching our video.